Hello everyone, how are you? I hope you all are safe at homes. This is Swati from Telangana Social Welfare Residential Degree College, Vikarabad. Today, let us discuss about optical fiber communication system. So before entering into the actual topic, we will discuss few points. Look at the slide. What are the modes of communication in olden days? Look at the slide. Two persons talking each other, and birds also used for communication, and after that they used to write letters, radio, TV, land phones, and after that mobile phones. Nowadays what we are using for communication? Look here, we are using smartphones with all the features like Facebook, Instagram, Twitter, whatnot, everything, right? But what is the major problem that we are facing with the smartphones? It's radiation, and the radiation has dangerous effects on human, like sleeping disorders, brain damage, skin diseases, generic disorders. Not only on humans, but birds also affected by this radiation. In the recent movie Robo 2.0, we have seen how the birds are dying with the radiation, right? So what is the solution for this? The solution is fiber optic communication. So let us see the history of this fiber optic communication. Who is the father of this fiber optics? Look here. He is Narendra Singh Kapani. He born in Punjab in 1950. First time he combined fibers with the lasers and used for data transportation. And after a decade, Sir Charles K. Cow, he used these optical fibers for communication for longer distance without energy loss. For his achievements, he got Nobel Prize in 2009. He is the father of optical fiber communication system. What is the basic structure of these optical fibers? Let's look into it. See, the optical fiber consists of 5 layers. And it is a innermost part, next cladding. So this is called core, and this is cladding, and the remaining all are protective layers. What is this core? The innermost part is called core. It is thin, flexible, glass or a transparent plastic material, and it is in a shape of cylinder, like it is having a diameter of 5 micrometer to 100 micrometer, and the outer layer of the core is called cladding. It is having lower refractive index than the core. Why it is like that? We will discuss in the working principle. And the remaining all layers are protective layers, and the diameter of the cladding is 125 micrometer, and for remaining protective layers is 250 micrometer. What is the working principle actually? The working principle in optical fibers is total internal reflection. What is this total internal reflection? The name itself tells that the total energy internally reflected into the same medium. See this. Look at the slide. First we will discuss reflection, after that refraction, then total internal reflection. So first reflection. Look at the slide. These are our daily life examples for reflection, and it is a boundary, it is a normal, and the light ray incident on the boundary with angle of incidence θ1. What happens? Whenever it is incident on the boundary, that will reflects back into the same medium with angle of reflection θ2. Here angle of incidence is equal to angle of reflection. Incident ray, normal, reflected ray, these three are in the same medium. But what is the defect in this? Energy loss. We can't get all energy reflection in the same medium, because some part of the energy refracted into the other medium. So next we will discuss refraction. Look at the slide. That is an example for refraction. What is that? We'll discuss here. Refraction. So here it is a boundary that separates two different mediums, and it is normal. It is air and it is water. Okay. What is the refractive index for air? It is 1, and for water it is 1.33. Here the water is having high refractive index than the air, means it is rarer medium and it is denser medium. So whenever the light ray incident on the boundary with angle of incidence theta 1, here the light is travelling from rarer medium to denser medium. So whenever the light ray travels from rarer medium to denser medium, it bends towards the normal with angle of refraction theta 2. We will see another case. I am taking here glass and it is air. Refractive index of glass is how much? It is 1.5 around, and for air it is 1. Same, the light incident on the boundary with angle of incidence theta 1. Now here air is rarer medium, glass is denser medium. Now the light is travelling from denser medium to rarer medium. So whenever the light travels from denser medium to rarer medium, it bent away from the normal. Can you see the difference here? See here, in the first case, the light travels from rarer to denser medium, it bent towards the normal. In the second case, when the light travels from denser medium to rarer medium, it bent away from the normal. Right? So now we will see total internal reflection. Total internal reflection. I am taking the second case in the refraction. This. It is a boundary and a normal, and it is air, it is glass. And the refractive index is 1.5 and it is 1. Now, the light is travelling from denser medium to rarer medium. Now, this is the angle of incidence theta 1. So, whenever the light travels from denser medium to rarer medium, it bent away from the normal, right? So, this is theta 2. If you increase the angle of incidence, see here, if you increase the angle of incidence, what happens? That will bend away from the normal again. If you keep on increasing, what happens? For a particular angle of incidence, the refracted ray lies on the boundary. So, this particular angle of incidence is called critical angle theta c. Again, if you increase the angle of incidence than the critical angle, what happens? The light reflected into the same medium. Here, without energy loss, all light amount is reflected internally into the same medium. Without energy loss, we are getting the light. What is Snell's law? Here, N1 sin theta 1 is equal to N2 sin theta 2. It will give you the relation between N1 theta 1, N2 theta 2. What are N1 and N2? N1 and N2 are refractive indices of the two different mediums. Theta 1 angle of incidence, theta 2 angle of refraction. See, to occur the total internal reflection, we have two conditions. What are the two conditions? One is the light has to travel from denser medium to rarer medium. Second one is the angle of incidence must be greater than the angle of critical angle here. So, if you remember the structure of the optical fiber here, the cladding has lower refractive index than the core. Why? Because to occur the total internal reflection in the optical fiber, the cladding has lower refractive index than the core. See here, the core is having higher refractive index, means it acts like a denser medium, and the cladding acts like a rarer medium. See, and not only optical fibers, we have so many examples of total internal reflection. Look at the slide. See, the sparkling of diamond. The diamond shines based on the total internal reflection, and also periscopes. Generally we used at submarines, and mirages. Mirages usually in summers or in deserts we can see, and binocular. These are all the examples, everyday life examples based on a total internal reflection. And look here, you can clearly observe the total internal reflection happening in a optical fiber cable. Okay, what are the types of classification of optical fibers? These optical fibers are classified into three categories. One is based on refractive index. It is two types. One is step index, another one is graded index. And the based on the number of modes, it is two types. One is single mode fiber, another one is multi-mode. And the based on the fiber material used, it is again three types. One, core and cladding, both made of glass, or core is glass, cladding is plastic, or both core and cladding made up of plastic. And we will see the block diagram of optical fiber communication system. Look at the slide. See, in that slide we are giving input signal. Then it might be anything, voice, image, video, non-electrical, analog, digital, it might be anything. We are giving input signal that will reach to the transmitter circuit. In that transmitter circuit we have two components. What are those? One is driving circuit, one is light source. So the drive circuit will receive the signals and it will convert those signals to electrical signals. Next, light source will convert these electrical signals into optical signals. Then we have fiber optic cables to the receiver end. So these optical signals travels through the fiber optic cables and it will reach to the receiver end. In that receiver end we have three components. What are the three components? One is photodetector, amplifier, signal restorer. Photodetector. That photodetector will receive the optical signals and it will convert those signals into electrical signals. And amplifier will amplify the signals, it will increase the strength of the signals. Then signal restorer, that will decode the signal and will give you whatever the desired form you want. And advantages and disadvantages. In olden days, people used copper cables for data transmission, but fiber optic cables has more advantages than the copper cables. What are the advantages? These are small in size, lightweight, and large data carrying capacity for longer distances, and low power consumption, low loss of data, and high signal security, means no tapping is possible, no noise while talking, and it is easy to maintain. And we have some disadvantages also. What are the disadvantages? See, the installation cost is very high, and comparatively copper cables, fiber optic cables are delicate. Then highly trained and skilled persons needed for the maintenance. Now, look into the applications. Look at the slide. Applications. We have number of applications, but few of them we discuss here. See, in medical field, I hope you heard the name endoscopy, right? Endoscopy, bronchoscopy, these are the medical techniques used to view the organs which are inside the human body, like endoscopy for stomach and bronchoscopy for lungs, like that, and arthroscope, it is like for joint replacement. And in military also we are using for decoration purpose, and in agricultural fields also we are using this fiber optics. Next, what is the scope of research? If you have interest, you can do research in nanophotonics, particularly in the area of fiber optic communications. Nowadays, everybody want high internet speed, right? So, if you twist the light in a shape of a spiral, that will give you 100 times faster internet speed. So, in upcoming days, we will get very high speed internet. And conclusion. I hope you understood the lecture. In this lecture, what are the content you learned? The fiber optic cables. What are the fiber optic cables? And the working principle is total internal reflection, and it is the best way to data transmission for longer distances, and it has many applications, and it is best way to reduce the radiation. In future we will get very high speed internet. Okay, let's do a small quiz. Look here. First question. The light in optical fiber is option A, refracted, reflected, straightened, total internally reflected. What is the principle that we are using in optical fibers? Total internal reflection, right? So, option D is the answer. And the second question, the outer concentric shell in fiber optic is called what? See here, the innermost part is core and the next layer is cladding, right? So, what is the answer? Option A is the answer, that is cladding. Third question. See, when a ray of light enters from denser medium to rarer medium, it bends. Do you need options? See here, we discussed whenever the light ray enters from denser medium to rarer medium, it bent away from the normal, right? So, what is the answer here? Option B is the answer, bent away from the normal. Fourth one, thin flexible glass rods to transfer data from one region to another are known as what? Obviously, it is optical fibers. Now, I have given two problems based on the total internal reflection. See this first problem. Light travels from air into an optical fiber with an index of refraction of 1.44. And what is the first question? In which direction does the light bend? And second one, if the angle of incidence on the end of the fiber is 22 degrees, what is the angle of refraction inside the fiber? First, what is the data given in the question you need to understand. Read the first statement. Light travels from air into an optical fiber. What is the refractive index of air? 1. And it is entering into optical fiber which is having a refractive index of 1.44. Means the light ray traveling from rarer medium to denser medium. So, whenever the light ray travels from rarer medium to denser medium, it bent towards the normal, right? So, what is the answer for the question A? It bent towards the normal. And question B, if the angle of incidence on the end of the fiber is 22 degrees, angle of incidence he has given, that is theta 1 he has given. And what is the angle of refraction inside the fiber? Angle of refraction you need to find. What is N1? N1 is the refractive index of air, that is 1. N2 is the refractive index of optical fiber, that is 1.44. So you know N1, N2, theta 1, you need to find theta 2. The answer also I have given, that is 15 degrees. I hope you can do this problem. And the second one, what's the second question? See, the light traveling through an optical fiber having refractive index 1.44 and reaches the end of the fiber and exits into air. It is exactly opposite to the first question, right? And if the angle of incidence on the end of the fiber is 30 degrees, what is the angle of refraction outside the fiber? See, you know, the light travels from optical fiber to air, means the angle of the refractive index is 1.44 N1 and the air refractive index is 1. And what is the theta 1 angle of incidence? Here it is 30 degrees. So you need to find theta 2, that is 46 degrees is the answer. Okay. Shall we close this class with a small assignment? I hope you can do this. See, what is the first question? What are the applications of optical fibers? Because of the time constraint, we discussed only few of them. Try to collect all the applications of optical fibers. And the next question, what is the main principle involved in this optical fibers? What is the main principle? Total internal reflection is the main concept in optical fibers. This you have to explain. Next, why cladding has refractive index lower than the core? Here we discussed, no? To occur the total internal reflection in the optical fibers, the cladding has lower refractive index than the core. You need to explain. Next, why is fiber optic technology faster than the copper? Why? Can you think? Because copper cables rely on electrical pulses, but this fiber optic technology rely on optical pulses. Right? What is the speed of the light? 3 into 10 to the power 8 meters per second, no? So that is why it is faster than the copper. All the best. Thank you.